Greetings, everyone, and welcome to the Pan Future Society podcast. I am your host, Sean, and today is Saturday, July 22nd, 2017. And this week, I got a little wordy and verbal with some things, so in lieu of the usual news bits, a little introductory essay comment thing here. It goes thusly. Words matter. The way you say something matters. The meaning of a word matters, and it matters that we agree on the meaning, and that we shouldn't arbitrarily change the meaning. You run into this a lot when people are trying to sell you something in particular, like, be afraid of chemicals. There's chemicals in your everything, or whatever. Especially if you're running into things that use sciencey sounding words. Anytime you hear a sciencey sounding word, I think you should pause for a moment and ask yourself, am I being sold something? Is the person using this word actually know what it means?
You keep using that word. I don't think it means what you think it means.
Listen to Inigo Montoya, people. He's a skeptic. He's a true skeptic there. Sometimes I think terms are applied to topics and they're not really properly understood, or in the way that a scientist might use a word is not often the way it's used in daily life, and the meanings get muddled. Global warming. It's much more than just warming, but climate change is a very big thing to wrap your head around. Global warming might be a simpler term, but it also kind of makes it just sound like hot weather. No one takes the time to understand more than just the few words in the tag or the headline to something. This came to mind recently when reading some further discussion about artificial intelligence and whether it is or will be dangerous. One perspective I heard gave me pause, and I don't think I'd heard it put this way before. We are developing more and more advanced algorithms, neural nets, faster computers, quantum computing. But even though some AI processing goes on in a black box that we can't directly observe, it's not really intelligence. I think that the term artificial intelligence is the wrong phrase in this case. Algorithms, neural nets, programming, yeah, all that. But intelligence? I think that implies choice. The day an Amazon warehouse bot plays hooky from work to go to a baseball game, that's true artificial intelligence. I think the term AI is overused and misused a bit. A program that helps doctors examine x-rays? Advanced, certainly, but hardly intelligent. Perhaps we can use the terms from the video game Mass Effect. In the game, a virtual intelligence is a simulation of intelligence, but with limits. It's often used, it's more of an interface. It makes it easier for the humans to interface with the computer if they think they're talking to another being. Artificial intelligence is truly independent and self-directed. I think we are actually a long way from a machine with self-directed agency. I'm not even sure we'll make a robot that can exceed the limits of its own programming, no matter how advanced it is. So, keep in mind, words matter. Pause to reflect on the meaning of a word being used, and reflect on who is using those words. All a little bit of food for thought for you. On to the main segment for this week. Are we alone in the universe? A question perhaps as old as human consciousness. Over the ages, people have tried to answer this question by assigning beings to natural phenomena, like gods in the storms, imps in the woods, or demons in our dreams. Beyond superstition, As we understand more and more about the real universe, it remains the biggest question for which we have mostly only guesses, perhaps even more unknown than that of the origin of the universe itself. As Arthur C. Clarke put it, two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. There are differing opinions about whether we should make contact or broadcast the fact that we are here, but I will save those for another day. Despite a lack of direct evidence, we can make some good educated guesses and fill in some blanks without resorting to superstition. And I say direct evidence in this case as in actual, verifiable, repeatable contact with aliens. Short of that, we have actually discovered the building blocks of life out in space. Organic compounds have been detected in nebula and in comets. But no one has stopped by to say hello. The Drake equation is an attempt to quantify how many civilizations there might be in the galaxy by assigning values to variables. Actually, it was originally intended as a thought experiment to guide research at the founding of SETI, the search for extraterrestrial intelligence. Frank Drake presented it as this, not as a hard math equation to figure out how many aliens should be out there. I won't get into the details here. I'll have some links in show notes and stuff. But even with widely variable numbers, there should be 1,000 to 100 million civilizations in the galaxy. Okay, there's a big difference in those numbers. It's a wide range, and that's kind of a flaw in the equation. There aren't hard data points to plug in there. We, here on Earth, are the only data point that we have. So a lot of the numbers have to be best guesses. It is, however, a fine launch point for discussion. There are an enormous number of hurdles to overcome just to be someone who can send radio signals into space. With billions of stars in our galaxy and billions of galaxies in the universe, I find it easy to believe that there is more life somewhere. Even by chance, there should be bacteria out there somewhere. But what does it take to develop intelligence? That's a factor in the equation. I think, though life might be fairly common, the exact circumstances that life needs to evolve advanced intelligence is tricky. What particular environmental pressures made us move farther away from the rest of the primates? If you watched the reboot of Cosmos with Neil deGrasse Tyson a few years ago, there's an episode that covers plate tectonics, among other things, and within that episode, I think is the most profound moment of the entire series, which is saying something. Our early ancestors living in Africa lived in dense forests and jungles. At the time, what is now Central America didn't exist. It had not risen above the surface of the ocean. As time passed, it did, and it changed weather patterns enormously. It dried out the weather that got carried across the Atlantic Ocean to Africa and created the savannas. It thinned out the forests, created wide open spaces between the trees, forcing our ancestors to, instead of going from tree to tree, to go down to the ground and cross some distance to get to another tree. And this favored walking upright. You can walk faster, you can run, you can then start to do things with your hands, which are no longer being used to get around with. And that is, just pause for a moment and think, is that what it is? Some random coincidence of plate tectonics, of the weather, of the environment that sets off some evolutionary pressure to favor one random mutation over another, and here we are. If Central America had not formed, if our ancestors hadn't lived exactly where they lived, none of this might have happened. That really is profound to me. I read another recent article that hypothesized that there may be many Earth-like worlds that are entirely covered in water. Water seems to be one of the necessities of life. And what if a planet with lots of landmass is actually kind of rare? Even if advanced creatures evolve on those planets, they might stay underwater forever. So I mentioned the Drake equation. There's also, you may have heard of the Fermi paradox. Basically, the universe is huge. There's lots of stars and lots of planets, and there's been lots of time. So where is everybody? There's a couple of possible answers to that question. One being the Great Filter hypothesis. This idea was first mentioned, written down by Robin Hanson, an economist, in 1996. And he describes a very interesting way of looking at the evolutionary path of life. I'll give you the list here. 1, you need the right location. 2, you need reproductive molecules like DNA or the precursors to DNA. Then you would get to single cell life, then a more complex single cell life. You get non-asexual reproduction. Then you get multicellular or complex life, which then would have to lead to tool-using animals with large brains, our proto-human ancestors. Then a technology-driven modern society, where we are now, followed finally by a colonization explosion, colonizing other worlds. And what the filter is basically is that at any point along this list of things, that hurdle is really, really difficult to overcome, and it could be extremely rare. I will link to some stuff in notes, and it gives a great graphic describing how this works. There are some variations on this, like to get to the origin of life, very common. To get to complex multi-celled organisms, maybe less common. There's maybe some sort of hurdle to overcome there. But I think this does kind of fall in line with my cosmos anecdote. It could be incredibly difficult to get to the point where you have technology that could be detected by someone listening to the sky, or it could be extremely difficult to get your species off its planet living elsewhere in the universe. Other interesting postulations I've heard is that we are either early or late to the party. I find early a little more likely than late, but civilizations might have limited lifespans, and maybe no one has been around long enough to make contact. Maybe just by chance we are the first to be able to beam signals into the sky. And our own radio signals have had time to travel only 110 light years. And those are our very, very first signals. What you might consider our noisy period of TV signals have only gone about 74 light years. The Milky Way galaxy itself is 80,000 light years across. If there are only 1,000 or 10,000 civilizations capable of hearing us, they might simply be too far away. Plus, signals in space, the inverse square law applies. Those signals may be too weak over such a great distance to hear, or we may be unable to compete with natural sources of radio waves. Also, perhaps civilizations attempting to communicate over great distances are using a technology that we haven't discovered yet. And the universe is a harsh place. Solar flares, supervolcanoes, asteroids, gamma ray bursts, and many other cosmic events may simply wipe civilizations out, or at least send them back to pre-technological times. Many civilizations, before they are able to leave their home planet, might be snuffed out. Even setting aside a cosmic disaster and keeping in mind that we here on Earth are our only data point, some have suggested that civilizations may naturally collapse through war, environmental degradation, the loss of resources, or simply time. Everything just has a natural run to it, and we only get so far. I guess we will have to see if we can save ourselves from ourselves before we decide how likely that may be. So, are we alone? Just given the law of large numbers and random chance, I think there must be some kind of life somewhere else, maybe even in our solar system. Bacteria might be common. Advanced technological civilization? Even considering the great filter idea, I find the numbers there favor there being someone out there somewhere. This is why I think, at least in part, the Fermi paradox really isn't a paradox, or at least makes some incorrect assumptions. However, I must also concede that the large numbers that support the chance that there is life also make it possible that we are so far away from them that we will never meet anyone. Maybe we won't ever even get confirmation that there is life somewhere else out there by picking up signals or detecting some chemical composition of an exoplanet. And if we truly are the only advanced, intelligent life in the universe, I feel it becomes even more imperative for us to survive, thrive, hoist our sails, and journey to the stars. It saddens me greatly to think that all the random events, chance, and time that has passed since the Big Bang has led to the fact that there are beings on one lonely blue dot that are capable of comprehending the universe, but who also seem bent on squandering such a glorious opportunity. All right, that's the show for this week. As always, and again, and will be again in the future, thank you so much for joining me. I really appreciate your ears and your brains. I appreciate you taking the time to listen to the show. Check out the show notes this week. I kind of made this week's thing a bit of an essay and stuff, but I gathered a couple of links that are really interesting and have far more details about the Fermi paradox, the Drake equation, the great filter, and that sort of stuff. So if you want some more details about that, I really do recommend go digging into the notes and check out those links. If you want to help out the show, go to the website panfuture.org, and there's a donate link there. If you would like to do something other than donate, you can write a review wherever you get your show, iTunes or Stitcher or whatnot, especially iTunes. That's a big deal. I think it's something like 80% of podcast traffic is still downloaded through iTunes. So you're out there. I know you're out there. Take a few minutes to give me some stars and some words on the iTunes page for the show. I would appreciate that so much. And that's all I got. Have a good week, everybody. I will talk to you again in the future.